that will be presented by Antonio Girona Garcia. Effects of prescribed fires for pasture management on soil carbon-related properties, a one-year study case in Buisan, Central Pyrenees.
Well, good morning, everyone. As I was presented, I'm Antonio Girona from the University of Zaragoza, and I'm going to present this work titled The Effects of Prescribed Fire for Pasture Management on Soil Carbon-Related Properties, a one-year study case in Buisan, Central Pyrenees. Well, the traditional mountain pasture management tool in the Central Pyrenees has been livestock grazing. But nevertheless, the decrease of this activity has led to a shrub encroachment dominated, among others, by Echinospartum horridum. This encroachment has increased around 47% over the last 30 years in the Pyrenees. Then, a good and suitable tool for the elimination of these species and the pasture and biodiversity reclamation could be the use of prescribed fires. Although I think there's no need to define here what a prescribed fire is, a good definition could be the one given by Wade and Lunsford that defines it as a deliberate application of fire to plant fuels in a specific area under selected conditions to accomplish predetermined management objectives. Nevertheless, the use of fire could imply some affection on soil properties. According to literature, prescribed fires are characterized by a low duration, low fire intensity, and low effective depth. Additionally, studies report neutral or even positive effects on soil properties, as a reduced impact on soil biological activity, low affection on soil organic matter, limited hydrological effects, or even nutrients release. Additionally, information regarding prescribed fires in humid subalpine environments for pasture improvement is scarce. Then the objectives of this work are to analyze the immediate effects of a shrubland prescribed fire for pasture reclamation or selected carbon-related soil properties, then study the evolution of these properties 6 months and 1 year after the fire, and do so at a detailed soil scale, from 0 to 1, from 1 to 2, and from 2 to 3 centimeters depth. The area of study comprises 3.8 hectares in Buisan in northeastern Spain, and this area is dominated by the Echinospartum horridum. It is located at an altitude of 1,760 meters above sea level, where the mean annual temperature is 5.7 degrees, and the mean annual precipitation is 1,270 millimeters. Soils that can be found here can be classified as calcareous leptic cambisol. Soil sample was carried out in a prescribed fire in November 2015, and 3 representative sampling points were chosen. In each of them, soil was scraped from 0 to 1, from 1 to 2, and from 2 to 3 centimeters depth. And then it was sampled immediately before the fire, immediately after the fire, and then 6 months and 1 year after the fire. Here we have a short video that shows the prescribed fire. As we can see, it's a low-intensity prescribed fire, very mild fire. And analyses were carried out in the smaller than 2 millimeter soil fraction. Total carbon and nitrogen was determined by an elemental analyzer, and from there we could obtain the total organic carbon and the organic nitrogen ratio. Additionally, we did a 28 days incubation assay from which we could obtain the carbon mineralization coefficient, soil respiration, and the microbial metabolic quotient. Additionally, microbial biomass carbon and beta-D glucosidase activity was determined. As we can see here, temperature was simultaneously recorded during fire with type K thermocouples, and at the soil surface at 1 centimeters depth, 2 centimeters, and 3 centimeters. As we can see in the graph, this red line shows that the highest temperature reached was on soil surface and was around 440 degrees. And temperature in the first centimeter of soil only increased 20 degrees. This could be explained by 3 factors: the low intensity of fire, high soil moisture, as we can see in the blue bar of the graph, and the high insulation capacity of soils. Well, data is going to be presented like this. On the vertical axis, we have the parameter that we analyzed, and the horizontal axis, we have for each soil depth, the 4 times. In blue, the unburned samples. In dark gray, the immediately burned samples. And in light gray and in white, the 6 months and 1 year post-fire samples, respectively. As we can see, these soils store large amounts of soil organic carbon. And as we can see, it's around 250 grams per kilogram. We can see a drastic reduction of soil carbon with fire in the first centimeter, that is around the 50%. And the same behavior, we observed it for the total nitrogen, that was reduced around the 40%, and it has the same behavior as total organic carbon. And both parameters were still the same 1 year after the fire. Well, as for the carbon-nitrogen ratio, we can see as is common in pyrolyzed materials, that with fire, the carbon-nitrogen ratio decreased with fire due to the mineralization produced by it. And no changes were observed after 1 year after the fire. Microbial biomass carbon is a very sensitive soil property. As we can see here, that it was remarkably affected even with this low fire intensity, being reduced almost 50% with fire. And no change, we observed no changes 1 year after the fire. Usually fire produces a decrease of the microbial carbon and organic carbon ratio as the labile fraction is more easily affected. But here we didn't observe any change as both parameters were equally affected. Here we can observe soil respiration. Soil respiration was the most affected soil parameter of the studied soil properties, suffering a significant decrease of around 70%. And it was the only of the studied properties that was affected even the 2 centimeters depth. And as we can see, it hasn't recovered 1 year after the fire. The carbon mineralization coefficient decreased significantly at the first centimeter, and it could be due to the decrease of the labile fraction. As for the microbial metabolic quotient, we observed no changes, even with fire, with time, or with depth. Here we can observe the beta-D-glucosidase activity that was drastically reduced by a 66% in the first centimeter. It is an extracellular enzyme, so this affection could be explained by the denaturalization of this enzyme. Well, as a conclusion, just say that the fire effects on the study soil properties were limited mainly to the first soil centimeter, except for soil respiration was also affected at the second one, that these properties suffered a remarkable decrease with fire, and that no significant recovery has been observed 1 year after the fire. And we want to thank a lot to the brief of Huesca for helping us and letting us to participate with them in the prescribed fires. If you are interested in our research, we have a website that is called fogosol.webly.com. And if you are further interested in this topic, we have also a poster in the poster area. Thank you very much.
Thank you, Antonio. Any question to Antonio?
Michael Bruce from Scotland. We do prescribe burning at similar altitude, not quite the same, but in these types of things. What was the soil depth up there? Because we don't burn on the top of ridges because of shallow soil depth.
We don't know exactly the soil depth, but it was at least 50 centimeters.
Okay.
Because we put some bars.
Yeah, and when you're operating at that altitude, would you not expect the recovery to be slow anyway? Are you going to go back and do more data collection in future years?
Yeah, we are planning to do a seasonal follow of the properties. This is the results up to last November, so it's 1 year post-fire, but we are going to keep assessing the effects. And we hope to see some recovery soon as vegetation is being recovered, the pastures are being recovered.
Any other question? No. I have a question for you, Antonio. How you measure respiration before the burn?
We measure in the laboratory. We take the samples, in the fresh samples, and we measure it.
Okay, it's not measured in field conditions.
No, we do it in the laboratory, the potential respiration.
Okay, it's only for microbial organisms, not including vegetation then?
No, not vegetation.
Okay.
We are talking here only about soil.
Okay.
Thank you very much, Antonio. Thank you.